Hi dear students and viewers, welcome back to our channel VINAY Kumar Basics of Physics. Dear students, in this video we are going to discuss about the errors and types of errors. Clear? This topic is very useful to the JEE, Neet, Eamcet as well as IP, Intermediate Public Examinations. That's why you have to watch the video till the end without any skip. Clear? What is an error? While we are doing any experiments in the laboratory, to measure the physical quantities we have to use some instruments. While we are performing the experiment, there is some possibility get the errors. Here what is the error? The uncertainty in the measurement value that should be called as an error. Uncertainty in the measurement that should be what we call error. So simply here, while we are measured some value by using some instrument, we are getting one particular value. Here what I am going to say, that is true value it is there, true value it is there. Clear? And we are conducted one experiment and we are taking some values, measured values. Clear? So there is some difference between these two. Difference of true value and measured value that should be called as error. That means what? We are not getting the exact value of measurement. Simply we are getting whether it is the value is less than or more than the true value. Then the difference of these two should be called here error. The uncertainty in the measurement should be called error. Clear? So here how many types of errors are there? Errors can be classified into the three types here: systematic errors, random errors and least count error. First one is, what is systematic error? Systematic errors means during the procedure we are getting the errors either in positive or negative direction. Either in positive or negative. That means only here what I have to say, it is in only one direction only. The errors which are occurred while we are taking the measurements in only one direction, that should be called here systematic error. The systematic errors can be arised in only one direction, either it is positive or negative. Generally the errors which we are getting in case of screw gauge and vernier calipers, they can be taken as example for systematic errors. Clear? The systematic errors can be classified into again here instrumental error, imperfection in experimental technique and personal errors. So systematic errors means what? We are getting in only one direction. The possibility of systematic errors in only one direction, either it is positive or negative, any one of these two only possible. Systematic errors in that first one is instrumental error. What is meant by instrumental error? While in the calibration of instrument, that means what? In the manufacturing of the instrument, is there any defect in the instrument and by using that instrument you are performing one experiment, then we are getting every time for every observation we are getting the error. Got my point? Already there is some defect it is there while manufacturing the device. Then while we are using the particular device during the practical examinations or practicals in laboratory, then obviously we are getting the error. That is type of errors are called instrumental errors. The errors which are arised due to the manufacturer defect they are called instrumental errors. For example, what we know the boiling point of water is how much? 100 degrees Celsius. 100 degree Celsius. You are doing the experiment by using some thermometer, but it is showing there 104 degrees Celsius. 104 degrees Celsius. Actually what is boiling point of water? 100 degrees Celsius, and but it is showing 104 degrees Celsius. It means that in this case of original one, correct one, the ID starts from here 0, 1, 2, 3 like that. But in this case, while when we are getting 104 means here it is starts with the 4 degree Celsius. So that type of error is coming under into the instrumental error. And one more example it is there. Here there is some wooden scale it is there. That should be up to some 30 centimeters. We are using the same scale from a long time. Then up to here, starting only we have 1 centimeter. Clear? The remaining should be here on off. It's gone. So that means what? Starting only we have 1 centimeter, and next year 2, 3 like that we have. That means what? 10 millimeters gone. It should be here on off. So now you are using that type of scale to take the length, breadth of some things water may be here. So by using that scale we are doing the experiment. Then obviously we will get the errors. So already there is no possibility to here correct the instrumental errors, because already that is having some defects. And how it can be corrected? If you can find out the defect in that instrument by adding or subtracting that particular magnitude of error, you can correct the instrumental error. See the second one, instrumental error. It's over. Now imperfection in experimental technique. We have to use the apparatus in a proper way. So then obviously there is possibility for getting less errors. In what way we have to use the instrument? In that way only we have to use. Other than that, if you can use in any other manner, some errors are erased. They are the errors due to the imperfection in experimental technique. General example for imperfection in experimental technique. What it is? If you can take a thermometer to measure the body temperature, the thermometer must be kept in our mouth. Other than that, if it is kept under the armpit, then it will show the less temperature of the body. Clear? If you can keep a thermometer under armpit, it will show the less temperature of the body. That is the one of the example for imperfection in experimental technique. Clear? For example, now it is a scale. And now we have to measure the length should be like this. Clear? So and keep here I am giving like this. So I have kept one mark here, and again next like this. Again next like this. We have to measure the length like this. So if you can measure like this, then it will show the more length or less length. The scale should be used in a proper way like this. If it is used like this, then we will get the wrong error. Generally in cloth stores they will cheat us like that only. They can keep scales like this. So then obviously we are getting the less cloth. Okay, leave it that. So simply here what it is, if the instruments are not used in a proper way, then errors will be erased. Clear? They are also coming under the systematic errors. And next one is personal errors. In title only we have story. What's that? Personal error. That means due to the carelessness or negligence of the observer while he was performing instrument or experiment by using some instrument, then some errors are erased. Those errors are called personal errors. Got my point? For example, while we are taking any thermometer and that should be kept in our mouth, to show to identify the temperature reading, we have to keep the thermometer in a proper way. If you can keep like this or like this or like this, then angle of visualization should be changes. When it can changes, errors are erased. Clear? So the type of error is called parallax error. What it is? Parallax error. Parallax error is coming under into the personal error. And personal errors are erased. because of improper arrangement. If the apparatus are not connected in a manner, correct manner, then also personal errors are erased. Okay, so that should be here personal error. And next thing here we have one more, it is there, gross errors. Gross errors. What is meant by gross error? You are did the experiment and you are observed that the value should be here 3.46 we observed, but while we are writing or mentioned or note in the any record, you mention like this 3.64. 3.46 is the actual reading what you observed, but it is noted as 3.64. So that type of error is also here what is called gross error. Those are also coming under the personal errors. So personal errors are only because of negligence and careless of the observer. There should be a error because of careless or negligence of the observer. That should be what we call here personal errors. Up to now we discussed about the systematic errors. Clear? Here the question is how systematic errors can be eliminated while we are doing some experiments. How? The solution is here. The first thing, systematic errors can be eliminated by improving experimental techniques, and number two, by using the instruments in a proper manner, and third one, by avoiding the personal errors. Clear? Systematic errors can be eliminated by improving experimental technique, and experimental apparatus should be used in a proper manner, and by avoiding the personal errors we can reduce the effect of systematic errors in our experiments. Okay, let's go for now random errors. What are random errors? So random error means the errors which are occurred in any direction, either they are positive or negative. In case of systematic errors, only one direction. If it is positive, then every time it is positive only. But in case of random errors, the errors may be in any direction, whether they are positive or negative. Sometimes may be positive, sometimes may be negative. So random errors in an experiment should be nothing but what it is, the errors which are occurred in any direction, whether they are positive or negative, they can be called as random errors. The random errors can be erased because unexpected, unpredicted things what happen in our surroundings. Okay, for example, we want to find out the current in a circuit. We are doing one experiment by using some apparatus. Clear? That apparatus what it is, by using some standard resistance, and in that circuit we have to find out the how much current flow it is there. Clear? So we are taking some 12 volts, just imagine we are taking some 12 volts battery that can supply the some here 0.6 amperes current. So here simply we want to find out the now current at 4 volts. Clear? Actually for 4 volts we will get 0.02 we will get. Just imagine for 4 volts how much we get? 0.02 we will get. When our main has some here input voltage to 20 volts. Just imagine here. If there is any sudden rise in the current, if it is we are getting the current more than the 220 volts, but here we are getting the more current. That means simply here my aim is to say, while we are doing current experiments, if there is any fluctuations in the voltage, the values what we are going to find regarding the current, they also changes. So they are the unpredictable, unexpected values. For example, another example is there. We are doing some heat experiments. Clear? So there is some sudden rise or sudden fall in the heat. How? For example, here you are doing the experiment very close to the open entrance of the door during the afternoon time. Already afternoon time outside temperature is more and you are doing some experiment with the heat, then obviously what we get, we will get the, for less temperature only we are getting the more heat. Clear? So very simply you have to remember like this, during the heat experiments and current experiments there is some sudden changes in the values. Due to that some errors are erased. Those errors are random errors. Sometimes maybe we will get a high voltage, then the current will be more. If you will get the low voltage, the current is decrease. If the current is increase, we are getting the wrong value. And if it is decrease, yes. So that means what? When if there is any fluctuation in the voltage, obviously we will get the either the output value current is maybe increase or decrease. In heat experiment also same thing. While doing the heat experiment, in the surrounding some more temperature is there, then the value of what we are finding temperature is we will get it very early, and that's the wrong value. In the surrounding we have some cool atmosphere. For example, we are doing the heat experiment in our lab. If you are doing the same experiment in cold countries, then obviously you will get some errors because of surrounding atmospheres. So that's why here we are not expecting any surrounding temperatures. There is some sudden rise or sudden or fall. So this type of errors what we call random errors. So you have to remember, random errors may be it is in positive or negative, and the random errors are erased because of sudden changes in the values. So for random errors, which example what? The errors what we are getting in the case of heat experiments and current experiment. Then how random errors can be eliminated? How it can be reduced? It can be reduced by taking the so many observations. Clear? By taking the so many observations, and again we have to take the average all of them. Then the random error is going to be reduced very less. Systematic errors can be eliminated, but random errors are not completely eliminated. Maybe there is possibility for reducing the error. It is not possible to completely remove the random errors. Clear? Let's go for now least count error. Least count error. First thing, what is least count? Least count is nothing but the least value can be measured by using any instrument. That should be called as its least count. By using any instrument up to what we have to measure the least value, that should be, it is what we call least count. For example, one scale it is there that should be calibrated in millimeters. The least value can measure by the millimeter scale is what? 1 millimeter. Clear? So look here, coming to the point, least count errors. The errors which are occurred or which are raised when the instruments are associated with the resolution, that means least count. To understand that, I will give one example here. What it is that the least count of the vernier calipers, least count of vernier calipers is 0.01 centimeters, and least count of screw gauge, least count of screw gauge is 0.01 millimeters, and that should be mentioned like this also, 0.001 centimeters. Here you want to find out the length of the one slab, glass slab, or maybe some cylinder, glass slab or cylinder, whatever may be. So this is the one cylinder. You want to find out the length by using the vernier calipers and screw gauge. In these two, screw gauge will use the accurate value because that should be measured up to 0.001 centimeters, but vernier calipers is 0.01 centimeters only. That means if you want to find out the length by using vernier calipers, we may get some errors. Why? Because it has least value up to 0.01 only. If you can change the instrument, we will reduce the error. So that kind of errors what we call least count error. So least count error means it should be associated with the precision or least count of the instrument. Clear? So least count errors can be eliminated or reduced by changing the instrument and by doing the experiment in a proper manner and by using the experimental techniques in a proper manner. So this is simply about the errors. What about systematic error and random errors and least count error? And along with we have some errors are there. Let's go for that. The topic is very important. Let's go for that. First we have to know about the what is true value. While we are doing any experiment, we will take the number of observations and we will note the number of measured values. Here why we can take the average of all those measured values. That is the question here. Answer for that. True value is the arithmetic mean or average of all measured values. All measured values is called true value. Is called true value. So for example, if you are taking A1, A2, A3, A4, A5 and so on, An are the measured values, then their average, so that is what we write here, A1 plus, A2 plus, A3 plus, A4 plus and so on, An by N. So here this is the average. In this we will take this average is now here true value or mean value. True or mean value. Clear? So this is what I nothing but this is what true value. True value should be nothing but here we are going to write true value is equals to, simply here we will write A mean. So again that should be equals to what? A1 plus, A2 plus, A3 plus and so on, An by N. So here what is the necessity for taking the average, and that average should be taken as true value. What is the reason for that? Let us see here. For example, we know that the value of G is what? 9.8 meter per second square. 9.8 meter per second square. So for example, we are doing some experiment and we are taking first observation should be like this, 9.4 meter per second square, and next one is G2 is 9.5 meter per second square and G3 is some 9.7 meter per second square. While we are doing the simple pendulum experiment, by using the simple pendulum experiment we have to find out the acceleration due to gravity. Clear? So we are doing the experiment only one time and that should be here 9.4 meter per second square we got. While we are doing the experiment we did so many mistakes, due to that some errors are erased. That's why the value what we got, that only here 9.4, that is the wrong value. So that wrong value never be taken as a real value. Clear? Why we are taking the multiple readings means, for that answer is here, when we are doing this some experiment there is some uncertainty in the measurement, that is what we call errors. So those errors can be modified by taking the average of all the measured values. Clear? And every time we will get some mistakes. Clear? Those should be rectified by taking the average of all measured values. That's why we will take not but one particular value as the true value. Clear? A mean is what just now we discussed, it is the true value, and measured values are what? A1, A2, A3, A4 and so on like that. Clear? So A1, A2, A3, A4 and so on, they are what? Measured values, and A mean is what? True value. Clear? Now first I want to write the absolute error. So we measured the value A1 by using some instruments. During that we got some error, that is what here? Absolute error of A1. that should be equals to here mod of true value minus measured value. This is the formula. Clear? Here what is true value here? A mean minus A1. So that is what here absolute error of A1, and that should be shown like this, delta A1. What is delta A1? Absolute error of A1. Now absolute error of A2 is like this, delta A2 is equals to mod of A mean minus A2. This is what? Absolute error of what? A2. And similarly absolute error of delta A3, that is what at here, delta A1, delta A2, delta A3 are absolute errors. We are mentioned delta A means what? Absolute error, like that. So here A mean minus A3, and now delta A4 like that, A mean mod of A mean minus A4, and so on, delta AN, that is what? Mod of A mean minus AN. So what you understand, A1, A2, A3, A4 and so on, AN are the measured values. Delta A1, delta A2, delta A3, delta A4, delta AN are the absolute errors of A1, A2, A3, A4. So delta A1 is what? Absolute error of A1. Delta A2 is what? Absolute error of A2. And delta A3 is what? Absolute error of A3. And delta AN is what? Absolute error of AN. So and so on. Okay. So now this is about the how we can write the absolute errors for different measured values. Now mean absolute error. So very simple here. In title only we have story mean absolute error. Mean means what here? Average, arithmetic mean. Simply here now A1 is the measured value and its absolute error is what? Delta A1, and A2 is what? Measured value and its absolute error is delta A2, and similarly here delta A3, and it is what? Delta A4, like that. Clear? Now we can go for mean absolute error. Nothing but arithmetic mean of or average of all absolute errors. Clear? The average of the arithmetic mean of the all absolute errors is what we call mean absolute error. Mean S is called mean absolute error. Clear, children? So how we can write? Simply here delta A mean is the mean absolute error. Delta A mean is equals to delta A1 plus delta A2 plus delta A3 plus and so on, delta AN by N. So this is the formula for mean absolute error. What is mean absolute error? Delta A mean. Clear? Let's see now what is relative error. Based on this formula we have so many problems. Relative error, what is meant by relative error and percentage error. So relative error should be like this: the ratio of mean absolute error and true value. The ratio of mean absolute error and true value is called relative error. Simply that can be expressed like this: relative error is equals to delta A mean. What is delta A mean? Mean absolute error. And what is true value? Yes, A mean. So the ratio of these two is called here relative error. What is relative error? Relative error is the ratio of mean absolute error to the true value is called relative error. And now here percentage error. What is mean by percentage error? Percentage error, if relative error can be expressed in percentage, then it is called percentage error. Simply here, what right here, what is here delta A mean? Mean absolute error by true value. Clear? So here now percentage of relative error, percentage of relative error, that should be expressed simply like here into 100, into 100. Relative error into 100 means what? That is percentage of error. Clear? So see once again here, what is true value? The average or arithmetic mean of all measured values is called true value. And what is absolute error? The magnitude of difference of true value and measured value is called absolute error. And what is mean? The average of all the absolute errors, what we call mean absolute error. And next, what is the relative error? The ratio of mean absolute error to the true value is called relative error. And what is percentage error? If we can multiply the relative error with 100, that should be called taken as percentage error. Clear? Now let's see one problem on this topic. Let's see one example what we discussed up to now. Those things should be here. We are going to solve. The question should be like this. The diameter of a wire as measured by the screw gauge was found to be 2.620 centimeters, 2.625 centimeters, 2.630 centimeters, and 2.628 centimeters and 2.626 centimeters. The diameter of wire as measured by the screw gauge. So he was given measured values like this. Clear? What do you want to find out? Diameter. That's why here first time we got this one is D1. I am going to say this is the D1 and this is D2 and this is D3 and this is D4 and this is now D5. So first thing what you have to find out, we have to find out the mean value or true value. Mean value or true value. How we can find out that? As D mean is equals to average of that one, D1 plus D2 plus D3 plus D4 plus D5. How many values are there? 5. That's why we can write it is 5. Clear? Then we can write D mean is equals to here. What is D1? 2.620 plus 2.625 plus 2.630 plus 2.628 by 5. So you can add them. 2.620, 2.625, 2.630, 2.628, 2.626. Clear? 5 plus 8, 13 plus 6, 19. 2 plus 2, 4, 4 plus 3, 7, 7 plus 2, 9, 9 plus 2, 11 plus 1, 12. So 1, 2, 3, 4, 5, 5, 6 are 30, 31. 1, 2, 3, 4, 5, 13, 13.129. So that is what here 13.129 by 5. So let's see here 13.129 by 5. So 5 ones are 5 2s are again 0.56 are 30, 5 2s are 10, 5 5s are 25 and 5 8s are. Then what is here? 2.6258, 5.6258. So here in all the values 3 decimal places are there. In this one 1 2 3 4 decimal places are there. That's why here it is, that is going to be round off like this 2.62. Here it is 5, 8 is greater than 5. That's why you write 5 plus 1. So 2.626, that is what mean value. And now we have to find out the mean absolute value of, or absolute error of everyone, absolute error of everyone. Here delta d1, what is delta d1? Absolute error of d1, that is what you have to write. What is the formula here? True value minus measured value, mod of true value minus measured value. So here what we got here, true value is 2.626 minus 2.620. So 2.626 minus 620, 26 minus 20, like that. So here already 0.006, 0.006. Here 0, 6 minus 6, 0. Again 2 minus 2, 0. 6 minus 0, 6. Okay. And similarly here delta d2, what it is? 2.625 minus, 626 minus, that is what? 2.625. Clear? That is equals what here? 0.001. And delta d3, that is what? Mod of 626 minus third value, what it is? 2.630. 2.630. Here what you get here? Simply 0, this 0.04. 0.04. 30 minus 26, minus 4 will get, mod of means what? Plus 4. And similarly here now delta d4, absolute error of fourth one, what is? Mod of 2.626 minus fourth one is what? 2.628, that is equals what? Mod of 0.002. And similar here now fifth one, delta d5 is equals what? 2.626 minus 2.626. Here 2.626 already was given, 2.626. Then what it is? Absolute error of fifth one is what? 0.000. So now this is about the absolute error of each measurement. Absolute error of each measurement. Mean absolute error. Mean absolute error. Mean absolute error. What it is here? So delta d1 plus delta d2 plus delta 3 plus delta d4 plus delta d5 by 5. Obviously what we know here? What do you know? S. This is what? Delta A mean. What do you write here? Delta d1, what is? 0.006 plus 0.001 plus delta A3 what? 0.004 plus, and delta d4 what is? D5 what is? D4 is what? 0.002 plus, and this is 0.000 by 5. So what do you know here? 0.0606, 0.004, 0.002 and 0.001. So 6 plus 4, 10, 12, 13. So then what do you get? 0.013. So here 0.013 by 5, 0.0026. 5 to the 10 and yes, 0.026. Here how many places are there? 4 decimal places there. Here how many there? 3 there. We have to round off like this. Then what is 0.0026 is equals to 0.003 we have. So that is what? Delta D mean. So this is delta D mean. So then here the diameter value should be written as, now therefore delta diameter is equals to D mean plus or minus delta D mean. This is the final value we have. Delta D mean is what here? 2.626 plus or minus 0.003. So this is the value of diameter. And now what we have to find out? We have to find out the percentage error or relative error first. Relative error also called as fractional error, relative error, or fractional error. What it is here? That is equals to delta D mean by D mean. Delta mean D mean by D mean. So what is delta D mean here? 0.003 by D mean is what? 2.626. That is equals to, we will get children here 0.001 we will get. Clear? So that is the percentage error, relative error. Therefore percentage of error we can write what it is, as is equals to relative error into 100. Relative error into 100. So this is what here, 0.001 into 100 means what? That is 0.1 percentage. How much error is there? 0.1 percentage. So in this way we can do the calculations. See the next example, same type of problem. The length of a rod as measured in an experiment is found to be 2.48 meters, 2.46 meters, 2.49, 2.49, 2.46 meters. So then we have to find out all those things as previous problem. Here length was given. So this is, I am taking L1, L2, L3, L4 and L5. Again 5 values. So first thing what I have to measure, true value or mean value? True value. What it is? L1 plus, L2 plus, L3 plus, L4 plus, L5 by 5. Clear? So then what it is here? So you have to substitute the values like L1 is what? 2.48 plus 2.46 plus 2.49 plus 2.49 plus 2.46 by 5. Clear? 6 plus 9, 15, 15 plus 9, 24, 24 plus 6, 30, 30 plus 8, 38, 38, 7, 2 plus 3 plus 4, 7, 7 plus 4, 11, 15, 19, 23. So 4 plus 6 plus 8 plus 10 plus 12. So 12.38 by 5. 10, 2, 3, 5 4s are 20. Again 5 7s are 30. Again 5, 12, 3, 8. 5 2s are 10. 5 4s are 20. Again 5 7s are 35. Again 3 s 2.476, 2.476. So here 2.476, that is what? True value. That is what I have to say, L mean. L mean is equals what? 2.476. So you can observe all the given values and note this value. So here how many decimal places there? In each one 2 decimal places. Now how many there? 3 decimal places. That's why it is going to be round off. 6 is greater than 5. That's why the preceding number is increased by 1. So that is what here? 2.48. 2.48. That is what? L mean value. What is? 2.48 meters. Now we have to find out the absolute error of each one. Delta L1 is equals what? Here L mean minus L1. L mean minus L1. So that is equals what? Mod of L mean value is what? 2.48 and L1 is what? 2.48. So that is equals what? 0.00. And similarly delta L2. L mean means what here? 2.48 minus, or it is 2.46. 2.46. That is what here? 0.02. 0.02. And delta L3 now. 2.48 minus 2.49. That is equals mod of minus 0.01. That is equals to here 0.01. And next delta L4. Delta L4 is equals to here. Delta L4 is equals to what here? Again 2.48 minus 2.48 minus again 2.49. So what do we again? 0.01. And next again delta L5. Delta L5. That is what here? Mod of 248 minus 246, that is equals to what? 0.02. 0.02. So these are the what? Absolute errors of measured values. Now what you have to find out? Mean absolute error we have to find out. Mean absolute error we have to find out it. So that is what? Delta A mean is equals to, so delta L mean is equals to what? Delta L1 plus delta L2 plus delta L3 plus delta L4 plus delta L5 by 5. So we can substitute here. Delta L mean, what you have to write? Delta L1 plus delta L2 plus delta L3 plus L4 by plus L5. Delta L1 plus delta L2 plus delta L3 plus L4 plus L5 by 5. Delta L1 value what it is? 0.00 plus 0.02 plus delta L3 value is what? 0.01 plus 0.02 plus, so again it is 1 plus 0.02, 0, 2, 1, 1, 2 by 5. So 0 plus 2, 2, 3, 5, 6, that is what? 0.06 by 5. Clear? Then what at here? Okay, 0.0, 5 ones are 5, again 3 is 0.016. So delta L mean is equals to what? 0.016. So in this expression we have 2 decimal places only. Here how many there? 3 are there. That's why here we have to round off this one. 6 is greater than 5. That's why 1 is added to the 1. So therefore 0.02. 0.02. Therefore the value should be written as L is equals to L mean plus R minus delta L mean. That is what here? L is equals to here. What is one? 2.48 plus R minus 0.02. Clear? Now what we have to find out? We have to find out the fractional value or percentage error. Relative error. Delta L mean by L mean, that is what? Fractional value. Clear? So what is now relative error? Relative error means what? 0.02 by what is 2.48. Now percentage error, delta L mean by L mean into 100, that is what here? 0.02 by 2.48 into 100. Clear? Then obviously we will get 0.40, we will get 0.4. See the next problem, same different example. The least count of stopwatch is 0.2 seconds. The time of 20 oscillations of a pendulum is to be 25 seconds. The percentage error in the time period is, the least count of how much it is? 0.2 seconds. The time of 20 oscillations pendulum is to be 25 seconds. The percentage in the time period is, so in this case we can write equals to T by N we can write. Then delta T is equals to what, right? Delta T by N we can write. So then from both these, from those two equations, what, right? Delta T by T is equals to delta T by N T by N we get. Then what it is? Delta T by T is equals to N cancel, delta T by T into 100. Clear? So delta T by T into 100 is equals to delta T by T into 100. What is delta T? Is 0.2 by T is what? 25 into 100. Then 0.2 into 25 by 0.2 by 25 into 100. 25 ones are, 25 fours are. Then what it is? 0.2 into 4. What do you get? 0.8 percentage. So therefore delta T by T into 100 is equals to what? 0.8 percentage. So if it is equation number 1 and it is equation number 2, what we are doing here? 2 divided by 1. Then what do you get? Percentage error of time period is what? 0.8 percentage. Okay. Dear students, if you can understand the content, what it is inside this video, please like, share, comment the video. If you want to expect more videos from my channel like this, please support my channel and share my channel to your friends also. Okay, thank you for watching.